This is the future of CQL, at least from my perspective. Hopefully by the end you'll agree. So who am I? I'm Bryn Rhodes. I'm a Director of Standard Strategy at Smile Digital Health. I'm an active participant in the HL7 CDS work groups, Fire Editor, CQL Editor. I've participated in the FirePath specs. So I've been around for a while, and to talk about the future of CQL, I wanted to start by talking about a little bit of the history of CQL. So if you'll indulge me, we'll take a stroll down memory lane. Around 2011, 2012, I joined a team that was building real-time clinical decision support for a EHR vendor here in the US. The kind of requirements for that project were that we had rapidly changing rules. We had to support the authoring and maintenance of those rapidly changing rules. We had to support governance around those rules. We had to support effective period for deployment because those versions changed over time, so you had to make sure you were running the right version at the right time that the setting had accepted. So we had real-time evaluation needs, so these had to run quickly. They had to be able to determine what data was needed. It was 2011, so pipes weren't as big back then, and we had to be able to control the size of the payload. And we had to be able to determine what we needed first versus what we needed later in terms of that evaluation. So kind of how you walk a decision tree to make sure that you're getting the data, all and only the data that you need to answer that particular question. We also had to support variability based on the setting. Where was this running? What were the provider preferences, parameterization, different thresholds, all of those types of things. And so our solution at the time was a context, platform, and model independent representation for expression logic. And if you know CQL, that should sound a little bit familiar. Supported static analysis to determine data requirements, so we could look at the content of the rule and decide what data that rule needed based on just some static analysis. And it supported reasoning on the result of that static analysis. So you could look at a set of rules and say, I need this data to capture all of those rules and run all of them at the same time. Again, bandwidth considerations were driving that. So we built that system. Worked pretty well, I think. Well enough that at the time, the Agency for Healthcare Research and Quality asked us why we built that instead of HQMF, which was a format that was around at the time for computable representation of logic. Health quality measures format, you may be familiar with that, we still use it today in kind of a different form than it was then, but at the time it did support basic expression of computable logic. There were various reasons we chose not to do that. We explained those reasons to them. And the result was they asked us to come tell them what we would do. And so we joined the Healthy Decisions initiative, and that led to the creation of CDS Knowledge Artifact Specification, along with Virtual Medical Record, which was something that was happening at the time, and Decision Support Service. So if you've been around in the CDS space for a long time in HL7, you'll be familiar with those. That CDS Knowledge Artifact Specification was effectively the same representation, and it was what is now ELM. It's the runtime representation of computable logic. After we built that, then Clinical Quality Framework came along and said, why are we using different things in measurement versus decision support? We're talking about things like inclusion and population criteria. We should be able to use the same stack across that space. And that's what led to Clinical Quality Framework, where we kind of broke the problem down into what are the things that really are specific to quality measurement, what are the things that really are specific to decision support, and what are the things that are common between them. So the metadata for how you talk about what the rules and measures look like, the common data model, like what do the rules run on, what does the information look like, and an expression logic. And so that initiative resulted in quite a few. These are all domain analysis models in HL7, published around 2014, 2015 timeframe. The first one is harmonization of health quality artifact expression logic. So we took all of the vendors at the time that were participating in that initiative, decision support vendors, quality measure specification vendors, and we said, what are the things that we need to be able to do? And we pulled that into a domain analysis model. These are the actual requirements for a language that would need to be able to specify these things. There's a common metadata conceptual model. What are the common attributes that we're all using to publish and share these things? And what does the data look like? That's the health quality improvement model. You may have heard of that. And then characteristics of a value set definition. This one isn't CQF, but it's super important, and it informed a lot of what came later in terms of how CQL uses terminology, because a key designer of CQL was also one of the people involved in characteristics of value set definition. And I bring all that up to point out that a lot of those ideas and that were published in those informative domain analysis models are what drove the definitions of some of the core resources in the FHIR clinical reasoning module. In particular, if you look at the metadata resource pattern, all of those knowledge artifacts share common metadata elements, and those are based on that harmonization of data element or metadata. If you think about the components of sharing logic, those domain analysis models kind of fall along those layers, right? You've got the model independent from the terminology and independent from the logic, because these things evolve at different rates, and we want to support separation of concerns. So CQL is really concerned with this top level. How do I represent the logic? How do I do it in a way that's independent of the model and of the terminology? So, end of history tour, and that leads us to what is clinical quality language. If you were in the CQL overview, this is the same slide, but what is clinical quality language? It's a domain-specific query language designed to represent and share clinical logic. It's clinically focused. It has a lot of constructs like terminology and temporal logic that are ubiquitous in clinical logic. It's platform and technology independent. It gives you an unambiguous representation of that logic that you can port to different systems. It's computationally complete in lots of important respects, arithmetically, it's interval algebra complete, it's relationally complete, and it's also functional, and I mean that in the language technical sense. It can't write things, it can only read. It's a pure functional language. All right, what is clinical quality language not? It is not a rule language. You can't write a decision support rule with CQL. You need a structure that lets you use CQL for the applicability logic. Like, you can't say when, then in CQL. You can only say if. It's not a measure language. You can't write a quality measure in CQL. You need a measure structure that lets you define how that population criteria relates to measures. And it's not a guideline language. You need all of the supporting structures. CQL is an important component of all of these different things, but it is intentionally not designed to build those things. It's designed to support building those things. It's also not a terminology definition language. I also get that question a lot. Can't I just define my value sets in CQL? No. That's the purpose of a terminology management system, and CQL lets you point to that, but it intentionally does not support that. So, the specification itself, cql.ho7.org, and now we're in kind of the current state. It's been published as a mixed STU normative specification for almost 5 years now. And some of the current projects that it's used in are quality measurement and reporting. Obviously, it's currently used with QDM to specify population criteria for ECQMs in CMS programs. And we're exploring the use of that for fire-based ECQMs and have been doing that at Connectathons for several years now. It's used in decision support. This is a diagram of how a clinical reasoning implementation making use of CQL can be established behind a CDS hooks interface and called that way. It's being used to support clinical practice guidelines. There was a session yesterday where we talked about some of this. This is a reference, or this is a link to an example implementation guide that talks about the WHO guideline for immunization for measles. This is just the measles recommendation. It's kind of an end-to-end example of a clinical practice guideline expressed using FHIR clinical reasoning and CQL. It's also being used in public health reporting for local distribution of rules. So if you have public health reporting events, right now those all get sent to a remote service that does rules. It would be great if we could distribute those rules to the sites where the events are being generated so we reduce the overall traffic. And that's what this ECR implementation guide does. And it's also being looked at for prior authorization questionnaires. This is a content implementation guide we've been working on to support expression or the use of population expressions common across prior authorization questionnaires. Those are just a few of the areas that I'm aware of, at least, that it's being used. Let's talk a little bit about current implementations. There are at least 2 open source implementations. Java Translator and Engine is at that CQ framework location. Fully open source, the code's out there. There are tons of issues and contributions. If you want to get involved with that, please do. There's also a JavaScript engine. And we also maintain at that link a list of community projects. That includes kind of known tooling projects as well as content projects. So if you have a project you're working on that's not on that list, let me know and we'll get it added. Another community, this is a more recent start. I think it was January of last year, something like that. I don't remember dates, but Digital Quality Implementers community is a set of vendors that are all working on building CQL engines. And the current focus of that group is on demonstrating engine conformance. So our starting point there was the CQL test suite that's published in the specification. The spec has a set of tests that are intended to demonstrate capability. We have a test runner that we built to just go walk through those tests and call a service, get the answer, and see if it's the right answer. So it's a community for engine implementation teams to collaborate on working through, do all of our engines get the same answer? And if they don't get the same answer, then we discuss why don't they get the same answer? We look at the spec and say, what does the spec say about what that answer means? And in the case that we identify an ambiguity in the spec, that actually gets fed back to the specification as a JIRA tracker. So that's current implementation. So now let's talk about vNext. So now we're at the future part. Took a while to get there, sorry. So clinical quality language vNext, if you are interested, that's the clinical quality language project page. We have a link to everything that we are doing there. All of the actual kind of management of the process happens in the CDS workgroup. We've got kind of 3 main themes. One is conformance, so supporting demonstration of conformance by engines and implementations, including the ability to advertise and support capabilities. We have feedback and features. So over the 4 years that it's been developed, we've gotten a bunch of feedback or that it's been published normative. We've gotten a bunch of feedback. We're applying that. We've gotten requests for features. We're considering those. And it was published as mixed STU normative. So most of the spec is normative, but there were a few things that we added as STU in that last ballot. So we're considering whether those things that were STU can be promoted to normative. Those are the three main themes. Before we get started looking at the specific things, I want to talk about what we will not do, and that is make any breaking changes. CQL is a published normative specification. It's been so for almost 5 years. Multiple production engines and systems rely on this stability, and so anything that we do to the language will be in a backwards compatible way. That should go without saying, but I just want to make sure that's very clear. All right. So the conformance theme, there's a definite need for engines to demonstrate conformance. As I said, the specification was published with a set of tests that demonstrate or that are intended to be used to demonstrate capability. And the JavaScript and Java engines use those tests as well as a suite of tests that they've developed themselves as part of their QA on their engines. But it would be great to make that something that's even more accessible. So that's what that DQIC is currently focusing on. The specification also defines a set of capabilities. Right now it's like literally a bullet list in the spec. So it would be great to formalize that and actually looking at making use of there's an application feature framework project going on right now that I think would be a great way to express those capabilities so that engines can advertise what capabilities they support, artifacts can advertise what capabilities they require, and you could, in theory, even support capability negotiation for, I need to run this artifact, what engine can run it? All right, feedback and uplift. So there's publication uplift. It was last published several years ago. There have been many changes to the publication ecosystem in that time, many enhancements and improvements. So one of the first things we want to do is get that uplifted. There's errata and clarifications, so things like definitions for compile time and runtime. We use those terms throughout the spec. We don't ever really define them. We just kind of assume people know what they mean. Clarify runtime type testing semantics for things like choice types, clarify implicit conversion semantics. Those are all things that as more and more implementations come online, those are ambiguities that are being surfaced in the spec, and we're getting those in. And then we want to formalize error reporting. There are quite a few places throughout the spec where it says thou shalt throw an error, but it doesn't give any coding or formal way to know exactly what that error is. We want to go through and add codes to those so that that can be a little more formal. And we also want to formalize JSON serialization of ELM. The engines all have this and do this right now, but there's no actual formal representation of that in the spec. So we want to get that in there. We also want to promote conformance language from the Using CQL IG. This is a new implementation guide that we just published. The content of that implementation guide has been pulled from like quality measure IG and clinical guidelines and refactored into kind of an all and only Using CQL with Fire IG that talks about things like how do you map between CQL and Fire types and how do you expose CQL operations in a Fire server. We also want to incorporate FirePath updates. So FirePath is also going through publication uplift and applying feedback. There recently were like 60 some odd outstanding trackers applied to FirePath, so we want to make sure that we're keeping up to date there and in sync with that spec. The key reason there is that CQL is actually a superset of FirePath. They share the same core expression grammar, and any valid FirePath expression is also a valid CQL expression. So if you've got a CQL engine, you can hand it a FirePath expression and it will run. That's an important thing that we synchronized as we were building both these specifications out, and we want to maintain that. Another one is default comparison precision. So in CQL, you can compare dates and times to levels of precision. So I can say, compare these two dates and times, but only to the month or only to the minute. That currently defaults to millisecond if you don't specify a comparison precision in your logic. So something like this right mastectomy procedure is going to say where the performed interval ends on or before the end of the measurement period. And that comparison is actually going to happen all the way to the millisecond because the measurement period is specified there. But if your data coming in isn't specified to that level, then on boundaries, you'll get, I don't know, because it's not going all the way down to the millisecond, your data coming in. Usually doesn't. So you can specify the comparison precision. You could say before end of minute of measurement period, and that would let you stop it. But measure authors have consistently told us it would be great if we could just default that. So we could say, we want all of the comparisons in this, unless they're overridden specifically in the expression, to be run to the minute, because we know that our data is going to typically run around a minute. So that's one of the kind of main features we're looking at adding. We want some additional terminology operations. We can currently say if X is in a value set, but we can't say value set contains X. I mean, you can say it, but what it does is use equality semantics. And so it doesn't really work because you're using equality semantics instead of equivalent semantics. Whereas the X in value set formulation does use equivalent semantics. It's actually a terminology operation. So we're proposing some tilde in and tilde contains operations to actually support that. They would effectively be in and contains, but instead of using equal as your membership test, you use equivalent. So that would actually kind of clean up some of how everything works there. Better support for profile-informed authoring. Right now you can kind of take a pure FHIR approach where you just say using FHIR and you write all of your CQL directly against FHIR. But there's also some tooling that will support taking a set of profiles and building a model that understands those profiles. So if you have slices for things like blood pressure or extensions for things like race and ethnicity, instead of having to dig into those extensions or look up the slices, we actually have first-class elements for systolic BP, diastolic BP, race, ethnicity. And right now, that approach happens inside the tooling itself, inside the model info. So what the translator outputs is pure FHIR, but the author sees a profile-informed approach. So one thing that we're considering is accessors. Right now, you can define a fluent function called birth sex that actually digs into patient extension, and then you can just say p.birthsex equals m. And that's sort of exactly what the profile-informed authoring is doing. It's just putting that logic to dig out the extension behind the birth sex element of the model info. So instead of doing that in the model info, we propose adding this notion of an accessor that lets you define that logic the same way you can with a fluent function, but then invoke it like element instead of function. Then there's not this thing happening in the model info, it just happens as a library instead of a model info generation. Same outcome, same effect, but that's a proposed approach there. So we're considering that. We're also considering type definitions. CQL currently does not have a mechanism to define types. You have to provide a model info to it. So instead of having to do that, we want to consider a defined type statement. This would actually have a bunch of kind of side effects. It would actually eliminate the difference between models and libraries. You would just say include QI core instead of using QI core. There wouldn't be model info. It would kind of take away the need for that. And it would significantly simplify the implementation of profile-informed authoring. So rather than the translator having to understand this mapping thing that happens in the model info, it just becomes a first-class part of the language to do that. And it would also, as a pretty important byproduct, enable better multi-version support. So next would be implementer support. We are considering approaches to simplifying implementation. We're looking at opportunities to reduce the number of types of ELM nodes. There are quite a few ELM nodes. We tried to strike a balance between implementability of those ELM nodes and the language on top of it. There are opportunities to simplify the representation of ELM. So there are, for example, currently multiple ways to represent some of the system function calls like conversion. So we're looking at, are there ways we can simplify that? We're looking at opportunities to use capabilities to facilitate implementations. So if authors could restrict their use of features to the set of features expected in a target, then you know you can run, and capabilities would let us identify those sets of features that are required. We're also looking for opportunities to move some system-defined functions into standard libraries. So some of the things that are defined right in the base spec right now might be more appropriate as just standard libraries instead of having that have to be in the specification itself. We're also considering a function type. ELM already has this capability. I have mixed reactions right here in the front row. Some yay, some nay. So ELM already has this capability. We use it throughout, right? If you're talking about a filter, you're using a function type to do that. We just don't, there's no facility in the language itself to support defining those things. So considering a function type, and you know, want to hear both sides of that consideration. There are some things that it would help a lot, but it's a significant thing to add. We want to also improve support for library organization and usage, allowing multiple versions of the same library to be included, so long as they have different local identifiers. This is a really important aspect of current versioning challenges. There are multiple versions of US core that need to be supported. So how do you do that? How do you actually support that with your artifact logic? We want to allow aliasing of included declarations. So when you include a library, you can call it something, and that's your local identifier. We also want to let you change the names of the things in that library in your library. And that's really only required because of fluent functions, but if you bring in a fluent function from two different libraries and they're called the same thing in those different libraries, you have no way to distinguish, no way to call them. So this would let you actually say, when I bring it in from this library, call it this. When I bring it in from here, call it Y, and then I can actually distinguish them. We also want to allow binding of parameters in included libraries. So if I bring in a library, I want to be able to say, my parameter should be passed to this parameter name in that library. Because sometimes, if you're bringing in libraries, you don't always have control over what things are named in those libraries. So we want to support that reuse capability by having a little more flexibility about how you bring something in without having to redefine the whole library. That would break the whole point. So that was kind of a whirlwind tour of new features of the language. This is now our balloting plan. Subject to change, of course, but phase one is a publishing uplift. Thanks to a heap of work by Brian Postlethwaite, there's already a branch that's very far along on this. The first kind of thing to do there is switch ASCII-Doc to Markdown. The spec was published with ASCII-Doc. Now Markdown is the way to go. And so we're doing just kind of a change there. The first phase is to complete that change and then do a side-by-side review to make sure that we didn't inadvertently change anything due to that uplift. Phase two is errata and clarifications, so apply everything that all the errata, all the clarifications that we've gotten so far, and consider a snapshot at that point. So this is, a 153 or a 16 that actually just has all the errata that we know about published and corrected. Then start in phase three with additional features. We're looking towards an STU ballot in January of 2025 with as many of those features as we can get in place. I realize that's an aggressive timeline. And then phase 4 is normative addition, possibly January 2026. So at that point, that's when we would kind of finalize this round. So that's the future of CQL from the specification perspective. I wanted to talk a little bit about the future of CQL from the community perspective as well. So community support is a big aspect of what we are trying to do. So education and capacity, we recognize there's a need for educational materials. There's tons of educational materials out there, and we're trying to create more. Considering a CQL certified for authors, what would that look like? Would it be useful? Looking at tooling, so how can we help authors build this content out? So VS Code plugin enhancements, one of the first things we're trying to hit is a debugger. There are lots of things that would be made much easier if we just had a debugger. So we've been working towards that. There are pieces of that in place, but we want to just be able to plug into the VS Code debugger and actually drop those in. We're looking at code completion. We're looking at go-to definition, references, things that most modern languages support from an IDE perspective, and just adding those in as much as we can to the VS Code plugin. Better support for CQL in JavaScript environments. Right now, in JavaScript, you can run it, but you have to have the compiled ELM. And so we're looking at ways to get better support for that, for ad hoc CQL rather than just compiled CQL in JavaScript environments. And then knowledge repositories, just places that people can share content, logic, best practices, that sort of thing. And then there's a CQL cheat sheet. That bit.ly will take you there. There's also at that a markdown version of this cheat sheet, and we are, if you see anything wrong with it, like we tried really hard to make sure there's nothing wrong, but if you find anything, let us know, and we'll fix it. All right, and if you want to learn more, get involved, the VS Code plugin user's guide, that is straightforward, just documentation for how to use that VS Code plugin. You can execute CQL, you can write tests, you can see the results, you can author, it gives you feedback about whether you've written your CQL correctly, and it also supports that right inside of a Fire implementation guide. So you can write your libraries of CQL, and they become libraries in your Fire implementation guide. We also do Cooking with CQL monthly sessions. The next one is at that link. Those are open to all, and you're welcome to submit examples as we try to work through those. The Zulip CQL stream is a place where we try to keep up with everything. You can ask questions, get answers, propose features, and discussions like that. And then the CQL vNext project, if you're interested in actually directly contributing and helping get the next version of this out, that's the project page. So you can find and reach me here. And questions? Oh, that wasn't somewhere. You're right. We do want to mention uncertainty. Sorry, I forgot to put that on the list. It's in the project scope statement. So uncertainty is a feature of CQL where, because we can compare date times that don't necessarily have the same components. I could compare a date time that was specified only to the day with a date time that was specified all the way to a minute. And if I ask something like, how many years are in between these two dates, the answer is uncertain because it depends what point you're talking about on that timeline. And so we represent that in CQL with an uncertainty. And that uncertainty will resolve if you ask to do comparisons against, so you can ask if it's greater than 6, and if it's off the end of a boundary, you know that it is. But if it's inside that uncertain range, then you don't know whether it is. And so that behavior, although it's important, is also surprising. And so what we want to do is provide some better language support for that. We're considering adding an uncertainty type to actually surface that, because right now it's implicit in the implementation. So that's another piece that we're looking at. Does that help? Okay, sorry, I missed that. Apologies. Right. All right, any other questions? All right. Well, thank you very much. Oh, wait. Thank you.
I have one more question.
Okay, good.
I used to do this too. I said a lot of we are, but who is we? Is that HL7 or a work group within HL7 or the DQuick community or if I wanted to participate, I know how, but...
Right.
How?
Who is we? So it's everybody, right? I mean, I wear a bunch of different hats. As the co-chair of the CDS work group, when I say we, I mean it's the committee that is stewarding that specification and is responsible for all of the HL7 process, so getting all the JIRA trackers, getting the ballot in place. So when I say we in that context, I mean participating as members of an HL7 CDS work group. But if I say we in the context of digital quality implementers community, I'm talking about participating as a member of a community of engine implementers that are all working together to try to figure out how to demonstrate engine conformance and provide that feedback back to the specification. If I say we as part of the VS Code plugin development, then I mean, well, we're saying that as with Smile as a corporate sponsor of an open source project, where we're trying to provide support to the community to use those features. So yes, I say we in a confusing way. But it is an uncertain way.
And if I want to discuss conversions between tuples of choices of function types, and I think that's a very bad idea, where do I go?
So for that, you go to the CQL Zulip stream, where we're actively discussing that topic, yes. And when I say we in that context, I'm just a member of the CQL community trying to address a problem that has been raised, yeah. No question? Okay, sorry. All right, thank you all. Have a great day.